Okay, so we have 3 lines of text, okay, and this input text, right, this 3 lines of text will be like this is a text file, this is the input file, and this input file is divided into the lines of text, right? And this each line will be given to the each different mapper machine. These are the different machines, right? So we can say Hadoop is a cluster, right, where the different nodes are there, and your data will be splitted into the number of machines. Because we are assuming it this is a one line, but ideally it will be a large text file. It's very large text file, and which will be divided based on the block size. Okay, so the default block size is in the Hadoop 2.x and 3.x 128 MB. So when this data is divided into the block size, so this just assuming that this one line is a one block size. So we are giving this one line will be given as an input to the one mapper machine. Second line will be going to the second mapper machine, and third line is going to the third mapper machine. And each mapper machine is giving each word is one count. So it just simply one count is giving for each word. Okay, suppose there are the 100 words are there, so each word will get one count. Okay, so once, but here like okay, so this thing is bus comma 2 is coming, but this is because of some combiner code is there. I will tell about what is a combiner. Okay, but ideally it will be giving for each word is one count, and what will happen then shuffling will happen. So here in between shuffling will happen. So what shuffling will do, the same key, because here is everything is going key value pair. This is key value pair, this is key value pair, this is key value pair, and this is key value pair. And this input also given as a key value pair, because every line has some position in the text file. Suppose I say this line is starting at the 0 position. This line is starting at the number of character in this line and starting in the, so every line has a one specific position, right? So I say this position is called offset. So what is offset in the MapReduce job? The position of the line is the offset, and when this line is given to the map function, this is the map function here, and map function is taking input. Here the map function is taking input, and this map function is taking input key value pair. So key is the offset and value is a line of text. Okay, again this map function is giving short shuffle and sort. Again here key and value, and what reducer is doing, reducer is basically aggregating the data for the same key. So if I say bus 1,1,1 is there, so it will become 3. Car 1,1, car 2, train 1,1, so it is become 2, right? So here is aggregation is happening. So when I'm saying the in the code, right, if you see, I told first is a driver class. So if I say here, if you see the configuration, so here is the some job. I created a job object, and I'm job object, I'm setting the driver class, mapper class, reducer class. There are the total 3 classes. One class is itself is a driver. This is called driver class, where we are doing all the job configuration. I'm creating a job, I'm setting the mapper class, I'm reducer class setting, I'm setting the output format, I'm setting the output key format, output value format, and input path and output path. And finally, once your control come back, I'm exit. Okay, so I'm checking. So my driver class is waiting till my all the processing is done. That is the reason if you see here the wait for completion. If wait for completion is true, then you will exit 0. So exit 0 is in Java is successfully job completion. If some error comes, so it will return 1, because this will be false, right? It will be returning false, and false means if this is returning false means it will come to the second part. So this is a conditional operator. If you have seen in Java, Python, okay, so it is a conditional operator. Like if this part is true, if this part is returning true value, it will go to the first, otherwise it will go to the else. Okay, and 0 is for successfully exit, and 1 is for failure. Okay, so what could be the failure? Failure could be like your program is not able to find the resource, or it is getting some error in the some other mapper machine or reducer machine, right? So it could be any problem. and this is a mapper class, and this mapper class is extending the some abstract class is their mapper. So how many parameters are there? Total 4 are there. So first 2 parameters are for input type and the last 2 parameters for the output type. So input type is you are taking this is offset long writable. So mapper is taking an input as a key and value. So value is the text of line and key is the offset. But in case of output type, so output type is key comma value. Here is a key comma value and this is key value. So this output type which is written here, context, right? So context is a variable which is shared between the mapper and reducer. So you know right here, mapper and reducer are different machines, right? So mapper is here, reducer is here, right? Mapper is here, reducer is here. So all these are the separate machine, right? This is a one separate machine and these are the 3 different separate machine. So how the data will be shared across the mapper and reducer through context. So context is like a shared variable where you write here in the mapper, in context you write, and shuffle and sort read from the context. Again, shuffle and sort write the context and the reducer will read from the context. So shuffle and sort is not our process. We are writing only 2 classes. We are writing mapper class and we are writing the reducer class. But Hadoop framework is performing the shuffle and sort. Once the data is written in the mapper, right? All the key and value is a 1, 1, 1, 1. So reducer will start the shuffling and sorting. So first it will do the shuffling and then it will arrange the key sorting. So if you see B is coming, C is coming, then T is coming and P is coming, right? And then reducer will start aggregation of the same key, okay, and aggregate the value, okay. So that logic is there in the reducer. So once we come here in the mapper class, so mapper class I told map function is there, and map function is this is taking the input type. So can you see long writable is a key and text is the value, and value is nothing but line of text. So whenever you are reading a file, so you are reading a line in a mapper because each mapper is getting the text of line, right? So once you are reading the data by mapper, right? So you are getting the line. So you know, right? Hadoop MapReduce is using the different data type because serializable data type. Because in MapReduce, your data is traveling over the network because one machine to another machine. So data cannot be primitive. You know, right? We are using a serialization. What is a serialization technique in Java? When you are saving your data in your machine, right, in the other remote machine, so you have to convert the data into byte array. And again, the data, this is called serialization. But again, the same, like the data will be deserialized. So serialization is when the data is converting into byte array. The data is converting into byte array. And other hand, this is called serialization. But deserialization is the byte array convert into primitive data. Convert into primitive data. Primitive data is original data. Primitive data is called deserialization. Okay. So here in Hadoop, there are the different data types are there, right? So when we talk about in Java, Java is having the data type is int. So here in Hadoop is having int writable. The int writable is a serializable type. Okay. So whenever you check in the Hadoop, the Java code, you will see there is a places the code, the type is look like this. Okay. So whenever you are writing data in the context or you are reading the data from like a context, right? So you will be having an int writable. So when you want to do some manipulation on the data, you have to call the get function, and you will be getting the value from the Hadoop type to Java type. If it is a long type in Java, so it is called corresponding long writable. Okay, long writable type. If it is a float is there, float writable is there. So one corresponding type is there. Okay, float writable. Okay, float writable. So it's a float writable. And if I say in Java is a string type, that is already a object type, and a string, and in the Hadoop is text type. Okay, so you will see the text. So then you look at here. So whenever like, okay, so text type data you can convert to, like it is already object type. So you can directly use toString and get the string data Java type. Okay. And once you get the Java type data, then you are doing the Java manipulation. You are splitting the data, because if data is separated by comma, okay, but my data is not separated by comma, my data is separated by space. What you will use here, you will change to this code. What you will do, you will change this code to as a space, because if the data is separated by space, if you see my data is separated by space, yeah. So when I'm getting a line of text, I will get the array after splitting the data, and each word in the array, this is a for loop. I will iterate the each word in the array, and what I'm doing here, I'm writing in the context my key comma value. So you know, right? Mapper is always returning the key comma one, right? Every key is a one value. So one int writable value I'm creating, because I want to write this data into context. So I have to make it int writable type. I told int writable, right? So int writable type, I made a one value. Okay. Suppose in the Java, how will you create this one value in the normal Java code? In the normal Java code, you write a code for making a one value. You write integer object like this. You take integer x equal to new integer one, right? So this is a normal Java code. But instead of that, you are making int writable, because this value you want to write into the context. Okay. So whenever you are writing something or you are reading, so you have to do conversion. So here I'm conversion is doing, like I'm reading the data and I'm converting to string. Okay. But when I'm writing the data, but key is again this key. So key is again I have to convert to the Hadoop type. So you remember, right? Whenever you are writing data, you have to convert to Hadoop type. So this string, right? Whatever the key is there, I'm making it as text type. Text type. I told like text is a Hadoop type. So I'm converting into the context dot write key and value. So here also I'm writing the data key comma value like this. This all. So I have completed my map phase. I completed my map. After this, once my map is completed, the shuffle and sort process is not our process. Okay, this is a Hadoop process, and Hadoop is doing shuffling across the machines and bring the same key together in one machine. Okay, so suppose I say bus is here, bus is here. So all bus it will find and collect one place. Car is here, car is here. So it will collect and find it in a one machine. So it is rearranging the data and sorting also. After that, sorting also is going. The next phase comes reducer phase. So reducer phase logic is a aggregation logic. I told reducer is used for the aggregation. So whenever you are writing a mapreduce code, so three classes you have to write. One for the driver and map and reduce class. Okay. So this reduce class has this reduce function. So reduce class also taking the 4 parameter. So first again the 2 parameter for input and 2 parameter for output. So whatever output you return here, okay, this one, this output from the mapper. Okay, after that you done shuffle and sort. So shuffle and sort is returning key comma value, right? Key comma value is a string type and integer type. Just normally I say this is string, this is integer, this is string, this is integer, and this is string, this is integer, right? So we can say string means text. So string means text type. So when I say I'm returning the text type value, I'm returning a text type value here, okay? And this output value is a int writable type. So here reducer is reading the same type, because reducer, even the shuffle and sort also reading the text and int writable, right? And the shuffle and sort also reading the same type. and reducer also reading the same type, text comma int writable. So after mapper, you will see everything is going text comma int writable, text comma int writable, right? So text comma int writable is going to the input to the reducer. So this is a reducer here. Reducer is here, and which is converting into the final output. Okay. So I say here text comma int writable. So text int writable, and output will be again text comma int writable. The final output is also text comma int writable. So reducer phase is here, is reading from the shuffle and sort. This is shuffle and sort. It is reading from the shuffle and sort and doing the aggregation here. Okay. And final output is again text comma int writable. So you can see the first two type is for input to the reducer is a text comma int writable, and output type is also text comma int writable. So text comma int writable means reduce is reading a text as a word, right, key, and int writable is the list of values, because it's not a single value, because here number of values are coming, like here is a bus 2,1, car 1,1, train 1,1. So list of values are there, list of integer values are there, int writable values are there, and context is common. So mapper and reducer both are taking context, because I told the context is sharing the data across the machines, right? From mapper to reducer, mapper to shuffle and sort to reducer. So this context is playing a role. Okay. So every time we write in context means we can get from the context in the next phase. Okay. So here I'm just creating a one like a sum equal to 0, like total equal to 0, and int writable type of values I'm iterating here. I'm iterating the int writable values, because the type of the values is int writable 1, 1, 1, right? So each value, and this is a numeric type, because in the like a text type data we can convert by using the toString in the Java type. But here, when you want to convert into the small int type, so you have to call the get function. So when you call value.get, like one value.get, you will get a one integer value, and you are adding in your sum. So how much sum will be there after completing this loop? As many as number of values are there. So here is the two values are there, 1, 1. Here is a 1, 1. Here is a 1, 1. But here is a 2, 1. 2 plus 1, 3, 1 plus 1, 2, 1 plus 1, 2, and 1 plus 1, 2. So this sum, again, we have to make it writable. I told whenever you are writing in the context, you have to make it writable type. So, but this key, I'm not making a text type, because it is already coming as a text, right? But here is a, I'm using this key and converting into the Java type, like string type, like word is a string. But this string word I have to convert to the text type. But here, this word is already text type. So I don't need to convert it as a new text, right? Like this, new text. Okay. Because already it is a text type. Because I have not done any manipulation on the word. Word is coming as it is. If you see in this particular code, are you able to see any manipulation on the word? No, right? You are doing only values, right? So you are just taking the list of values and calculating the total sum, right? And this sum you are converting as a from integer to again int writable. So here is a two conversion is there. One is int writable to make normal int value by using the value.get. And once it is converted as the integer type, small int type, then you can do the sum. After getting sum, again you need to convert into the int writable type. So these are the writable type is basically making it your data serializable. Like across the machine, your data will not transfer like integer, character. It will not transfer like that. It is transferring the data over the network by binaries, right? 0, 1, 0, 1, computer machine learning language is the 0, 1, 0, 1. We call it, right? So if I'm writing something here and I say this line I want in the another machine, how can I get it? I cannot get it like a text, right? I can get it text over there, but it will not transfer the over the network will text. It will be converting as a serialization. So serialization libraries are there in the Python, there is a pickling and depickling libraries there. In Python, there is the pickling, depickling. Okay, you will see that pickling and depickling. Okay, these libraries are used, right, making it serialization. But Java is providing a serializable interface. Okay, so serializable interface is a marker interface. Okay, okay, those are the Java concepts. Okay, marker interface, there is no method. There is no method marker interface, but it's a giving the instruction to the JVM, like any class is a serializable type. Okay, any class is implementing the serializable interface. So the class data should be serialized. The class data should be saved as a byte array, and it will be transferred over the network. Okay, so serialization plays a very vital role when you are doing the distributed computing, when you are transferring the data over the network, right? So the data is transferring into the packets, and these packets are the carrying the data is a binary format, right? Okay, so the byte array data will be transferring over the network. Okay, so MapReduce job. So because MapReduce, we are not processing the data only one single machine. MapReduce is the framework which is processing the data over the distributed number of machines, like a cluster set of machines are there, and then data is crossing a list of machines, and then you are getting the output on one machine. So this output is the final output. Okay, so word count is giving you final output like this. So when I say this program, right, I have written this Java program, but what to do with this Java program? I have to execute this program, right? So there are the two ways. One is a development purpose. You can run in IntelliJ. You can test your logic. Okay. And one is you can create a jar of this project. You can create a jar of this project, and then you can do Hadoop jar command. Okay, there is a Hadoop jar command to run your job in the cluster. So Hadoop jar, and your suppose your jar name is the abc.jar, and your driver class, you give the driver dot my driver class name, and then you give input path and output path. Okay, when you run this job in the Hadoop cluster, when your Hadoop is running and you run this job like this, so you will see one output file will be generated, and that output is your MapReduce job output. Okay, so first of all, we have to write this MapReduce code. Okay, and this MapReduce code is not like just 3-4 lines of code. It's like maybe 150 lines of code. So I'm saying most of the times, like, we are not writing from the scratch everything. We have the skeleton, right? I know map function skeleton is there. Just I need to put the logic here in the function. Same like a reducer function, I have to write the logic. And same like a driver class, right? So in the driver class, only I have to change my class names of the mapper and reducer. If my mapper class name is this, I will change here. If my reducer class name is this, I will change it here. Okay. And my driver class itself name is this, I will change it here. And that's it, right? If you write a program and then create a jar of this project, and then you can execute the jar. But IntelliJ, if you have this program, just right click and run as a Java program, because this is having the main function. So you guys know, right? Main function is there. You can run as a Java main class and you can get the output. Okay. So I will show, this is a very high level. I explained what is a MapReduce program, right? I still telling you, right? MapReduce program, you don't need to use in your like any companies. Nobody will ask you to write this entire program. But if somebody is asking you, like, can you tell me what is a map and reduce function? You have to explain, because if you understand, like, you have the knowledge of the map reduce concept, then only you can understand anything internally, how it is happening. Okay, because I can say, okay, Hive I know, Scoop I know, HBase I know, but do you know, right, how it works internally? Because everything in the Hadoop ecosystem component is using the MapReduce. You are not writing the MapReduce code for that, but internally it's using. But this is the directly we are writing the MapReduce code. Okay, so MapReduce is good like when you want to write a custom Java code, right? So that kind of flexibility is here, right? You can write your custom logic, right? So I can write even the image processing logic, right? I can write audio, video processing logic. but I need to use the APIs. Normal Java APIs will not be providing any image processing. So these are the Java APIs, right? So these are the Java APIs we need to use. Can we reduce the Python to write MapReduce? Yeah, we can write, but Python MapReduce is, you can test locally, but you cannot use Python MapReduce in the cluster because it's a single threaded. You will not get the distributed computing and parallel processing advantage in the Python MapReduce. Python MapReduce is very simple. So Python MapReduce code word count, it's like a two file you will create. One Python file is a mapper file, and one Python file is your reducer file. So py, right? Two py file you will create. One like this. One mapper.py, one reducer.py. Okay. So this is trying in the Hadoop cluster. Okay. But it will be running, but it will be not running as a distributed computing. Another way, local testing you want to do. Suppose for local, right? Like you want to run the same MapReduce code locally. So for locally, like you want to run the local code. So you have to write a two file. So one file I written mapper.py. So mapper.py, what I'm doing here, I'm reading the input from the keyboard, or suppose I'm reading from the data from the some text file. Okay. So I'm just doing the same logic here. Each word I'm giving one count. Can you see here? The logic will remain same. Whether first you are splitting the data. First you are breaking the data split you are doing. Can you see? This is a split is a space because there is nothing you are passing in the split, right? So it means you are splitting the words, split the line and getting the words. Once you get all the word in the list, right, you will get a one list of word because you are joining the, after the splitting, you are joining in the list, right? And what you will get it? You will get the list. How to iterate in Python list? For word in words, right? This is the list, right? And each word you are giving one count. So you are printing just word comma one, word comma one, word comma one. Every word you give in one count. Suppose your text file, your input file has 100 words. So each word will be one count, no matter the word is repeated. Every word will be given one count. Okay. Then reducer.py file, what is doing? It is reading your this word comma one and finding which word is the same word, right? So then it is making a pair. Can you see here the pair? So what is doing here? It is pass the input we got from the mapper.py. So suppose I got the word comma one I got, and I'm just getting each word comma one. Okay, and I'm checking if the word is the same word, then count is incrementing. Count equal to count plus count one, right? So I say I'm incrementing my count one by one, right? Okay, so this is the logic. It looks like a complex, but more simpler logic you can write. But it's the same logic, whatever you written in Java, the similar code we write in Python. Okay, so when we so we are doing the increment, and then finally we will be getting the word comma count. So right, in the dictionary you use, right? In the Python, normal Python, you can use the dictionary, right? Suppose I have a dictionary, like I can create a dictionary of word comma count, right? So if you have list of words, convert dictionary of word comma count Python. So what will be the logic? This is the same logic. Like you have list of words. So suppose you have like one string and you split it, you got all the word in a one list, and you created a one empty dictionary, and you are checking each word, and then you are checking if the word is present. So you are incrementing. So here it's not a correct logic. So you are doing, if word is present in your dictionary, okay. If it is not in dictionary, you will give the first time one count. If it is present in the dictionary, take the value and increment by one. So this logic will finally, after populating, your dictionary will be having your dictionary will have the word comma count will be there. Okay. So this is simple logic in the Python you write. Okay, word count. Okay. So you are giving the every word is a count one, and then you are aggregating the count. Okay. So here map and reduce both are working together, right? Because in the one condition you are giving one count, and the second condition you are doing count equal to count plus one, you are aggregating. So it's dynamically happening, map and reduce both together in a one single for loop condition, right? But if you are doing separate, so first same logic, like whatever logic we written in Java here, so this logic you will convert into Python. How will you convert? Like you are getting some line of text, and each line you will split by space, and then uh, you will give like a word comma one, right? Word comma one. And once you have this word comma one, you are reading all the word of the same key, and then you are aggregating. So Python code also you can write, but that Python code is not distributed, right? Okay, in the cluster. Okay, or you can write in the PyCharm also mapreduce code. Okay, so map and reduce two Python file you have to create. Okay, so you say like you need a two Python file. Okay, see, Python doesn't have inbuilt-in MapReduce framework, but you can easily simulate the process. This thing ChatGPT is saying. A MapReduce job usually split the data into the independent chunks, which are processed by the map task in a completely parallel manner. The framework sort the output of the map, which are the input into the reduce task. And finally, the reduce is aggregating. So if I'm writing a map function, so if you want to do, there is the Python provided map function is there. So what map function does? Like map function is applying the operation on each element, right? So instead of multiply, what I can do, this x I can return comma one as a dictionary, as a tuple type. I can return a tuple, right? X comma one, right? Okay, but this one is doing like I'm doing multiply of the same number, and I'm returning the out. So what will come? 1 into 1, 2 into 2, 3 into 3, 4 into 4, 5 into 5. Here is reduce function is basically doing the aggregation sum. Okay, so if I want to do the sum of these number, so there is a one right, in the Python also one reduce function is there, right? Reduce. Okay, that is the action basically. So the reduce is doing two number, it will take, it will make it sum. Then again, whatever sum you got it, like in these two number, then make it sum with the third number. So whatever you got from these three number, then add with this number. So finally you will get 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15. So 15 will be the output of this reduce function. So basically, if you are doing right, so this map function one output will be, you are getting the square of the number. Okay, but you will get the same numbers, right? Same like 1 into 1, but the number of elements will be the same. The number of element will not change, because map function will work on each element and give the and return the same number of elements. So if I do multiply of the each element, so final output will be the 5 only, na 5 number of elements, right? If 1 into 1, 2 into 2, 3 into 3, 4 into 4, 5 into 5. So what you will get? 1, 4, 9, 16, 25. This will be the output of this one. What will be the output of this? The output of this is like addition of these numbers. So you can say, I can write a one def function, and I can write a sum function and take the for loop I run. The for loop you are doing, right? Can you see here any for loop is there in this reduce? No, right? There is no for loop. I'm just I'm iterating, right? This reduce is itself is applying for each element, taking a two element together and doing the sum. Again, taking a two element, then doing sum. Again, this is the iterative approach itself. So you are not writing any for loop is. So if you have seen, reduce example, right? So if you see reduce, right? Reduce. So map and reduce, two functions by default is given by the reduce and map function example in Python. And you can implement using lambda also. You can implement the same thing using lambda, right? So lambda will be giving more flexibility, right? You can use lambda keyword. Okay, so lambda, like you can use map function and you are using lambda x, x comma x, and you are providing your list data. When you want to apply the reduce function with the lambda, so simply two element you needed. So you are avoided here just writing the function. You are writing a function here, right? Map function and reduce function. So lambda is basically avoiding the writing function. It is giving anonymous function. Anonymous function is function without name. It is working itself as a function. This lambda is itself is the function logic. This is a function logic, right? Can you see here any function name is there? No, right? It is not, right? There is no function. So in this code or this code, what is the output? Output is same. The only difference is here you are creating same logic with the function, and this function you are passing to your, this function you are passing to the map function. But this logic, this x into x logic you are applying here in the map. The same thing what you did here with the lambda, you have used lambda, so you are not writing a function. So you completely avoided function, right? So lambda is the anonymous function, right? You don't need to define manually the function. So map is everywhere, right? Map is in the Spark Hadoop is there. Map is in the Java is there. So map is means do any one operation on each element of the list of values. Okay, that is basically the map. So same thing map in the, if you have seen here in the Java, right, this map function. So this is also we are doing the same. I'm taking each value of your line of text and applying 111. Okay, so my logic, if you have seen, I'm giving map function 1, 1, right? 1, 1, 1, 1. I'm giving like this, right? So this is the logic I'm writing. Okay. So how to write a code? See, if you understood the map reduce logic, then you can understand map reduce logic in the NoSQL databases. Mongo also having map. Everywhere map reduce, right? So map reduce logic concept is same everywhere. If you understood one place, you can understand anywhere. But the syntax is different. When you are going in the Mongo, so MongoDB is having the aggregation framework is there. That is map reduce framework. Okay. So map reduce is like some places you have to write a huge amount of code, like Java map reduce you have to write in Hadoop. But if you are going in Mongo, just 3-4 lines of code, because they have provided a wrapper. Okay. Okay, so that's the reason you don't need to write a entire like a Java code. Okay. So when you come to, like, first we need to have some project in IntelliJ. Okay, so we have to install the IntelliJ. So I have already told about the IntelliJ, right? So IntelliJ is the editor for the Java program, right? So Java and Scala you can use IntelliJ. So I will be starting my IntelliJ. So you go to the bin directory, and here .idea.sh, and you start the Hadoop service also. So Hadoop service we have to start. So start right on all.sh. My Hadoop service is already running. That is the reason it's saying to me stop it and run again. Okay. So I can check my Hadoop service is already running. JPS command we can check. Okay. So even though I'm not running on the cluster, first I'm showing you the MapReduce program in the local. Okay. Like in the IntelliJ I will show. So I will be, so first of all, because I told you the MapReduce program you can run at two places. One is in IntelliJ, you can test your logic of your MapReduce, and same logic you can run of the MapReduce logic, you can run on the cluster. Okay. So you remember last time I did in the same project, I did the SDFS code, right? Like SDFS, Java API, right? Different copy file, create file, like all this we done. So now we are checking like a MapReduce program. So word count job, this is my driver class. So I created 3 classes. But if you have seen the example which I shown on the website, that is there is a one single class, but that class has 2 more classes, inner classes are there. But I'm not using the inner class concept. I'm just keeping it my 3 separate classes. So this is my word count job, that is my driver class. And this is the word count mapper class, and this is the word count reducer class. The driver class logic is very simple. I'm creating a job object. I'm setting my job to the jar. Like I say, my driver class is the main class. Because if I'm specifying this, so my MapReduce program, when it will run, so it will understand your driver class is the starting point because it has the main function. I cannot jump to the mapper or reducer because without starting the driver, because driver is the main function. Okay? And here is I'm setting what is my mapper class name, what is my reducer class name. Can you see one combiner class is coming? So combiner class name is both are same, right? So combiner is called mini reducer. Sometimes you will see, now you will understand why it is bus comma 2. Okay, because of combiner. So sometimes if the value is repeated in the same mapper, right? In the same mapper, when it is the same mapper machine, the value key is not value, key is repeated. So what combiner does, it will aggregate in the same machine as a mini reducer. See, reducer work is to get the keys from the different machines, right? It is coming, bus is coming from here, bus is coming from here, plane is coming from here, and plane is coming from here. So 2 different machines. So that type of work is done by the reducer. But combiner, they made it a local reducer. So combiner is a local reducer, and reducer is the reducer is like which is taking the data from the different machines, like keys from the different machines. But if the same mapper machine, if the key is repeated 2 times, and if you are applying the combiner, what it will do, it will aggregate in the same machine by using the same reducer code. See, code is same. Either you apply in the local machine or you are applying on the like remotely, right? Basically, which is taking the data from the different machines. Okay. So combiner code, reducer code is same for both, but we have given the name as combiner. So combiner purpose is basically when your data is so many times repeated, right, in the same mapper machine, you can apply the combiner. If I don't want to execute the combiner, I will simply comment this line. So if I just commented this line in my job, the combiner will not be added. Only mapper will be added. Okay, and reducer will be added. Okay, there you will see one more thing is there partitioner. What is partitioner does? Suppose I say this output is coming and you are getting one single output file, but I can make it, suppose like here I say 100,000 words are there. Can you read the word count of 100,000 word in a single file? It is very tough, right? So if I distribute my output into multiple output files based on the some condition, suppose I say if my word is starting with the B letter, it will go to the one single file. If my word is starting with the C letter, will go to one file. Can you think how many maximum file will be created? If this kind of logic I want to apply, max 26 file will be there, because in ABCD we have 26 letters, right? So either the word will be starting with A letter, B letter, C letter, D letter, T or P or Q, S, right? So only one single file will be there for all the words of the same starting letter, right? So this part is done by the partitioner. So partitioner is basically like making it your output file into number of output files so that the user can read the file, right? I can find my specific word in a specific file. If I say my word is a starting with a B letter. Can you go other 25 files? There will be no point to check those 25 files. You will go to directly B starting letter file and find your word. And it will be more easy, right? If you have to 100,000 word and one single word you have to find in 100,000 word in a single file, or if you say like one particular file which has just 1,000 word, or maybe okay, maybe 10,000 word, right? So it will be easy. It will be easy in the less number of words. Okay. So that kind of logic is basically implemented by the partitioner. So partitioner is a separate class also. So combiner, partitioner. So combiner is, we don't need to write a separate class, but partitioner we have to write a one class, because in case of combiner, we use the same reducer class. So I don't need to write a separate class for the combiner, because combiner is the logic is the same as a reducer. Okay. So that is the reason combiner is called the mini reducer. So what is the advantage I'm getting by using the combiner? The advantage is the less word will be travel over the network, right? Suppose this bus is repeating 2 times. Is it fine? It's fine, right? Because 2 is very, very less. But if I say if this bus is repeated 100,000 times in this mapper, what will happen? 100,000 times 1, 1, 1, 1 will go. Okay. So you can see how much bandwidth will be there, how much overhead will be there. If I say bus comma 100,000, if I do aggregation, that is better, or bus comma 100,000 time is better. Now you will say, okay, bus comma 1, 100,000 time is not better, because if the same key is there, why I should give 1, 1, 1, 1, 1? If different word is there, that is fine, because that will be definitely 1, 1, 1. But if same bus word is coming 100,000 times in the same mapper, it's not a good idea. So combiner is greatly reducing, it's improving, greatly improving the performance, right? So that's the reason we apply the combiner. So this bus comma 2 is coming because of the combiner. Okay, so combiner is applied at the mapper side. Okay, partitioner also applied at the mapper side, so that we can decide which word will go to which file. Okay. Okay, we run the program without map, combiner and partitioner. So I'm making it comment. So this is optional. Combiner and partitioner, these are the optional. But partitioner, right? Mapper and reducer should be there. Even the sometimes if you think, okay, there is no need of reducer, so we can have only mapper also. Okay, so your output is coming directly mapper. So your output will not be using the reducer. Suppose there is no calculation. Suppose I say, I have my input file is the emp.txt. Okay. And this emp.txt, I have a ID, name, age, city, right? I just want to display the data. Okay. So I can read this file and simply write the output in some formatted way. I say ID will come, then some comma will come, and some separation letter will come, right? Like say dollar will come, separation letter. Like this, I will be showing the output. So here is no need of any reducer, because there is no logic required. So that type of job is called only mapper job. So at least mapper is needed, right? Otherwise there is no point of mapreduce mapper. So at least mapper is there. So that is called the mapper job only, identity mapper. Okay. But reducer is choice. Okay. Because if the reducer is not required. But partitioner and combiner is completely optional. If you think your logic is really needed combiner, then you can apply combiner. If you know the data is repeated more number of times. Okay. And if you think your data need to be divided into the number of output file, then you will definitely go for partitioner also. So I will show the partitioner class. First we check in this Java class driver class, we are setting the mapper class, we are setting the reducer class, and mapper output key class. So what mapper is generating the output? What is the key class of the output of? This is the final output one. The final output is a text comma int writable. This is generated from the reducer. Okay. So mapper output is not there, only reducer output. So here it's not, reducer is not written. It is simply output key class. So this output key class and output value class means output of the reducer. Okay, so that is we are indicating our output key class is text type and output value class is the integer. Okay, so I'm setting the input format and output format, and I'm setting the input path and output path and the system.exit I'm good. Okay, and there is a logic, right? Suppose I want to delete my output directly. You know, right? Whenever any mapreduce code or any Hadoop command you run, right? You know, right? You have to create a new output directory. So output directory, generally, either you have to give a new directory always if you are not deleting manually. Okay, if you are deleting, so you can have a code, this can logically delete it before writing a same output directory. So once it deleted, then same output directory it will write. So this logic is basically delete your existing output directory and writing to the same output directory after delete. Okay, so you don't need to give new one. Okay, so this is the top. And the mapper class, the mapper class having the map function, and map function logic is same, like whatever logic I explained to you, this is the same logic. Like you have an input and you are splitting with the space, and each word you are giving one part, imperatively one. And you are making your word as a text type when you are writing to the context. Okay. This is the mapper logic. So other logic is the setup function, or these are not required. Okay. Okay. So and reducer class is having the simple logic, like your total sum is there. You are reading the each value from the values and you are doing the sum, and then finally you are writing as a key comma value. You have to write a result as an iterable. So this is a simple MapReduce program. So how to run this program? So you have to create the one application type. If you go to the edit configuration, plus icon, and you create an application type. So here you will create a new type. Okay, I say new add one. Something you give which is not present here. Okay, and then you give the main class. The main class we have to give the driver class. Word, count, job. This is my driver class, the main class. Once you give this, and this is a directory, on which directory this class is there. Okay, once you done this, okay, and next thing is you have to pass the parameter. This is mandatory because you are reading in the driver class these two arguments. So I have to tell where is my input file and where is my output directory. Suppose I am taking my input file. I'm just taking an example of an input file. Okay, suppose this input file with the different spaces are there, right? This is the country names, and I have a space. Okay, I make it this file large. Same words are repeated, right? Multiple times. So we don't need to copy this file into Hadoop file system, but when we are running on the cluster, so my input file and output directory will be on the cluster. But for this particular editor, right, where we are running, so it is locally. So my file will be here in the local. Okay, how many lines are there? 36,624 lines are there. Right? So if I say one word is a unique word, that is not in the, so it will be these many times will be there. Okay. So let's start. So I will save this file. Okay. My file is a XYZ file. Okay. I keep it in a some directory. So while I will come to know my output directory is created. Okay. I go here and paste it here. So my input file path. What is my input file path? This is my input file path. There is no extension of the file. Okay. So this is my input file path. I will write it here, my input file path, and I will give the input file name. And I want to create a one output directory in the test one. I told you test one is already there. You can't give the output file in the test one. You have to give some new directory. I say output one, some directory name. So in this output one, some file will be created by the default name. Like you don't need to, you can't give the name of that file. Okay. So mapreduce will give the file name is something part hyphen r hyphen 0000. That file will be created in this output. I apply it. Okay. And then I can run my program. Okay. And like I start the timer, like how much time is taking in the. Okay. Now I start timer. So, and oh, it's completed. I think 10 seconds. Okay. So let's see. If you are getting the exit code 0, I told it successfully exit, right? I say in the driver class, if you are getting this exit code 0, it is successfully exit, right? So there is no error, right? So if I verify, I have the directory output one file is created part R. Can you see these many number of times? How many lines? Or see how many times is this word is there? These many times. Actually, these lines are 18,000 lines. Oh, some line is not having this word. Okay, okay, understood. Okay, every line doesn't have the word, right? Okay, so the line numbers lines are 36,000, but one line has not this word, right? Okay, so only 18,000 lines have this word. Okay, if you see here, you can get the count, right? How many times this one? 18312 total, right? And this is the position of the word is a 10,996, right? So how many, what is count I'm getting? I'm getting correct count or not? Or which word you want to check? Okay, I do one thing. I just change one extra word I give. You will come to know how many extra time is there. Okay, I just put it this word. Okay, or two time I. Okay, now I save the file, right? And you will see I'm not deleting directly. I'm just keeping my same output directly. I'm not deleting. I'm just running my code. Because of this delete, automatically it will create the same name directly. Okay. Okay. My code is done. Now, same output one directly. I go here. So this 3 is coming. Ask to reload. The file is changed. It will ask to reload. Yes. Okay. Where I'm taking input file? Can anyone tell where I'm taking input file? Are you guys paying attention or not? Please, you can tell me, right? Where is the input file? My home directory, right or not?
Yes,
Right. My home directory, I'm using this file.
test
Okay.
one. Yes,
And where I'm modifying it, where I'm modifying it. I'm modifying this directory, right? I'm modifying this file, right? My data is in this file, correct? So
yes,
what should be the path of the file? What should be the path? The path of the file should be this one, right? This one, right? Okay. So that is the reason the file remains same, right? Why I'm not getting any update, right? Because it is still reading the my home directory file, the original file, which I not copied in this test1 directory, right? So I'm reading their test1.txt there. So I'm reading some test1.txt file, okay? Not XYZ, okay? So I have to give here XYZ,
yes,
okay? Now I'm giving the correct input file, and now I'm expecting the output here. Actually, the word count dot, yeah. So this one, and here I have to change my output directory also. If suppose output one to line. Okay. Okay, so new directory is created, output one to. Can you see now it's changed? Two more.
yes. Two.
It was the problem is like I was like there are two spaces are there. So it is somewhere like two extra spaces will be there. It is taking that space is a word also. Okay, that is the reason you say something is not appearing, but this is a space. The space is a word also. Somewhere the space will be there in this file. Somewhere the space will be there. Now we cannot recognize that where the space. So that space is taken like as a two count. Okay. So this is basically the word count and which is giving you the, if you enable the, right now I have not enabled my combiner, right? If I same this combiner class I enabled, my combiner is disabled. If I know, right, there's so much repeated word is there, 10,000 times, 18,000 times the words are repeated, right? So if I apply the combiner, just I make it enable the combiner, and now I run the same program, like how much time it takes. Just have to enable the combiner. Class is same, reducer class, but I'm using, see, some fractions of second you got, right? So you got some speed, but it is still less number of word repeated. I'm saying if the words are the like 100,000 times words are repeating, okay, then it will be getting you very, very fast, okay? Because as many as word repeated, the combiner will be, you will get the advantage. But combiner will be no advantage if your words are not repeated, right? There will be no advantage. It will run as a same like a normal method, okay? When you see here now, output 1, 2, output will remain same. See, now new output is trying to come because it is loading the file. If I there is change any output, output will never change. It is just processing it with making it faster. Right? The combiner is basically aggregating the keys in the mapper side as a reducer. Okay, so whatever you do in the reducer, right, the same thing is you are doing local mapper. So local mapper, you are aggregating the keys which are the same, but reducer is doing the aggregation of the keys from the different machine. So that is the key difference between the mapper and combiner and the reducer. Okay. Now, if I say I want to apply the partitioner, so partitioner is a class, right? So I have written a separate class. So I told you I will write a one class and that will have two input values. One is a key and another one is a value. So everything is given in the mapreduce key value. Everywhere key value we use. Either you are talking about mapper or reducer, input or the mapper, input, output of the mapper, input to the reducer, output to the reducer, output from the reducer, partitioner input or partitioner output. Everywhere the combination is a key value. So here is key is coming and int writable is value is coming. So what I'm taking here, I'm creating a one get partition function. Actually, this get partition is given by this partition. I'm just overriding and writing my logic. So here I'm passing a one parameter number of reduced tasks. So this number of reduced tasks means I want to say how many output file you want to generate. Suppose you say, I want to generate 3 output files. I want to generate 3 output files. So number of reduced tasks you are getting 3. What I'm giving here. Let's see in the driver class. Driver class I'm giving number of reduced tasks 3. The number of reduced tasks 3 means the 1, 0, 0, 1, 2. 3 files you want to create with the name. One is a 0, one is a 1, 0, 0 file, 1 file, and 2 file. So when I say if number of reduced task is coming 0, then only 1 file will be there, only 0 file. But number of reduced task is coming 3, so 3 different file will be there. One for starting letter with G. Okay. So suppose I say like starting letter A will go to one file, starting letter G will go to second file, and other word will go to the rest of the word will go to the third file. So how many files will be created? 3 output file will be created. Okay. Just you have to write this logic. Return 0 for A letter starting word. You can write 26, right? But I'm just showing it. If I want to create total 3 files, one with the A letter, one with the G letter, and rest of the letters starting anything. I'm not taking care of that. Okay. Because maybe like I want only A letter words. So I'm just concerned about this file, or I'm concerned about this file. Okay. So, but you can write the 26 times this if else condition 26 you can write. So you will get the 26 file. But some of the files will have no word, right? Maybe it depends on your words you are using, right? The letter of the word in the starting of the word you have. So just you have to write one partitioner class and apply this partitioner class in your driver. Just add these 2 parameters. First you tell your partitioner class name and your number of reduced tasks. So this partitioner is applying on the mapper output and distribute the output into the number of reducer file. Okay. Now same code, same logic I'm running. Okay. Just only I have enabled partitioner and I have created a one partitioner group. Everything will remain same. My code is done. Okay, it's done. Now I go to output 1, 2 directly. Can you see 3 files are coming here? part R 000, part R 001, part R 00. Part R you go, reload, there is no word. So A letter, any word is there? I believe A letter is no word. Let's see, XYG file. A letter, no word. Any letter A? Like A is coming in the middle, but starting letter A is not there. If you see the country name, any country with the A letter is not there. First three lines you can see because it is repeating the same lines, right? A letter is not, but G letter is the word is there, right? If I go to the second file, part R001, so Germany is coming. Germany is coming. Rest of the words will be going to the in one single file. Got it? So this is like an example of partitioner, right? How you can make it your output data into number of output file, reducer file, output file, so that you can easily read. And the same code we can run on the cluster. I will show tomorrow how to run the mapreduce code in the Hadoop cluster and create a jar. I have to create a jar. Okay, and jar option is very simple. You have to have Maven code. The Maven project, right? Like clean build. So you already know, right? Create a jar for clean package we use, and this will create a jar. So when I run this Maven, so it will create a jar, and this jar I told, right, we will use it in the target folder. We have jar, and this jar we run on the Hadoop cluster. But for that we need our input file on the Hadoop file system. We cannot use, but this jar you can keep it locally, but you have to have input file. So suppose here, this is the same input file. Okay, so I start a terminal here. I keep it jar here. I keep it jar here, and I start my terminal here, and some Hadoop directory. Plus minus 2 XYG, and I have a directory test 231. Okay. So this directory I uploaded my file. So now I will use the command Hadoop jar, Hadoop jar. I will the jar name mapreduce snapshot jar driver class. Driver class I have to give with package name. So what is the package name of my driver class is org example word counter. Okay, I have to give with complete package with word count job. Okay, and after that input path. What is my input path? Test 231 slash my file name XYG. What is my output path? Test 231, and I give some output directory. So that directory should be new directory. What we are going to do. When you run this command, now this code is running on the Hadoop cluster. And for this program, you should have your Hadoop service running. Otherwise, your code will not run. Okay, so it is also doing, you are showing here map 0% initially, reduce is 0. Map is 100% completed, and then reduce will be 100. It is reduce is doing step by step, right? Okay, now it's done. Can you see the output came, and it is showing how many record it read? 151, and it written. It's a byte it's showing, not record. It's showing byte. Actually, our record is showing this. So 36,626 rows it read, and how many rows it written? 164,812. So, oh, this is a map output record. So your reduce output record. Seven lines should come only. Yeah, reduce output record. This is a 10. The total lines of 10 will be reduce output record. Reduce output record is 10. Okay, reduce output record 10. And when you see this output, Hadoop fs minus get command, and you can do test 231 slash op slash part r part hyphen r hyphen 000, right? What the directory name is. Mhm. Just implement it. Let's go to back. Okay. Oh, three part file. Oh, my partitioner logic is working. Okay. That is the reason because I didn't change the code, right? So same code run here. Okay. OP slash part hyphen R. Output will come same, right? Whatever your local running or you are running. Okay. Oh, first file is empty. You remember, right? First file is empty, right? 001. I didn't remember. That's the reason it's an empty output is coming. This is empty. Okay. Cat command. So you will see second file is for the G letter. So you will see Germany is coming, right? When you change here to, it will be coming other, right? So so you can see total 10 is coming. So 2 line, 3, 4, 5, 6, 7, 8, 9, and 1 line is in the German. The total 10 output record lines are coming. Okay. Okay. I share the recording and share this code. You can do practice. Okay. So MapReduce is completely Java based. Okay.